Hello and welcome to Cashmatics. You may have already studied trigonometry in school and used the acronym SOHCAHTOA. Now SOHCAHTOA is used to calculate unknown sides and angles in a right-angled triangle. But what if the triangle isn't right-angled? Well, that's where the sine and cosine rule come into play, and in this tutorial we'll be looking at the sine rule. So grab yourselves a pen and some paper and let's get started. So as I said in the introduction, the sine rule is used for non-right angled triangles. And the question must involve two angles and the two opposite sides to these angles. And it's one of these four things which you're trying to calculate. So let me just draw a triangle up. So there's a triangle. And the way the sine rule works is this. The sine of A, so the sine of angle A divided by A, is equal to the sine of angle B divided by B, which is equal to the sine of angle C divided by side C. Now it's quite an easy one to remember this, but what you can also do with this formula is flip the whole thing over. So A over sine A is equal to B over sine B, which is equal to C over sine C. Now just pay attention to where the sine is. The sine, it always goes with the angle, okay, and the side that's opposite the angle has the same letter just in lowercase instead. So that's how the sine rule works. And what I mean by you need an opposite pair, so let's say for example the question involved this side and this side, then it'd have to involve this angle and this angle. So these are opposite pairs of sides and angles. Okay, so you've got 4 bits of information there. Okay, now you'll know 3 of them, and there's one of them you're trying to work out. So for example, you might know this side here, and you might know this side here, and you might know this angle here. And this is the thing you're trying to find. So that's what I mean by you're trying to find one of those 4 things. Now I'll go through some examples and I'll give you some questions to try, and hopefully by the end of this tutorial you'll understand how to use it. Now you might be wondering why there's 2 versions of the sine rule. One's just an algebraic rearrangement of the other. But if you pick the version smartly, then what you can do is you can reduce the amount of working you need. And the way I decide what I'm going to do is I start by writing the thing I'm trying to find, okay, and make sure that's in the numerator. So in this case here, I'm trying to find a side. So if you look at this version here, this is the one where the sides are in the numerator. So start by writing the thing you're trying to find, which is x, and divide that by the sine of the opposite angle, so over sine 30, is equal to the other side that you know, which is 10 divided by sine 80. So 80 degrees is opposite that 10. So that's one opposite pair, and that's another opposite pair. And all I need to do then is rearrange it to make x the subject here. All I have to do is multiply the other side by sine 30. So it'd be 10 sine 30 divided by sine 80, which equals 5.1 centimeters to 1 decimal place. I'll do another just to make sure you understand what's going on. So just as before, start by writing the side you want to find. So I want to find y. Divide that by the sine of the opposite side. So divided by sine 110 equals the side that you know, which is 8, divided by sine 35. Okay, so then rearrange it to make y the subject by multiplying the other side by sine 110. So 8 multiplied by sine 110 divided by sine 35, which equals 13.1 centimeters to 1 decimal place. So remember what I said, start by writing the side you want to find, divide it by the sine of the opposite angle, and that equals the side that you know divided by the sine of its opposite angle, and then just do your rearrangement and put everything into calculator and you should get your answer. Right, so here's 4 questions for you to try. Now the first 2 are going to be straightforward. The second 2 I've thrown in a curveball, and when you get to it you might be able to work out what it is, but the first 2 will be straightforward. The next 2, I'm giving a warning, are a little bit trickier. So pause the video, give them a go, and hopefully you won't fall into the trap I've set for you. So I'm about to reveal the answers in 3, 2, 1, and here we go. Okay, so the first two are straightforward, and you can pause the video and read those if you want to. Now the second two, remember what I said about having an opposite side and an opposite angle. So that 8 centimeters is opposite, is not opposite an angle. It's opposite this angle over here, opposite this 30 degrees. Okay, but the question had 20 degrees and 130 degrees. So it wouldn't work, so I'd have had to work out this angle over here first. And the same goes over here. This side D, which I'm trying to work out, is opposite this angle over here. So this is the one I need to work out first. So just remember, angles in a triangle add up to 180. So it makes the problem quite straightforward, but you've got to make sure you've got the right combination of information. So hopefully you didn't fall into that trap, and if you didn't, well done. If you did, then just look out for it next time you have a question like this. Now in these two examples, we're going to be calculating an angle. Okay, now because we're calculating an angle, I'm going to use this version of the formula. Okay, so that has the angle on top. And what you also got to remember is at the end of it all, you're going to have to do the inverse sine function to work out what the angle is. So let me just show you what I mean. So the angle I'm trying to find is x. So I'll start by writing sine x. Okay, sine x divided by the side which is opposite it, which is 12, is equal to the other angle, so sine 40 degrees divided by 10. So when I rearrange this, I'll get sine x equals 12 multiplied by sine 40 divided by 10. And what I'm going to do here is I'm going to work out what sine x is. Okay, so I'm going to work out what this is by typing it into the calculator. And that works out to be 0.771, and it carries on. Now what I tend to do is I leave that on my answer on my calculator. And the next stage is to do the inverse sine of that. So inverse sine of 0.771. Okay, now remember that's stored on my calculator. So if I do the inverse sine of that, so all you need to type is the inverse sine and then press the answer key and then press equals, which works out to be 50.5 degrees. Okay, now if you're not comfortable doing that, just type in the inverse sine of 0.771. Okay, so let me just do that. The inverse sine of 0.771, and that equals 50.4 degrees. Okay, so there's a slight difference, but that's because of rounding errors. Okay, so if you can, just do the inverse sine, and then if you press answer, the answer key, which is next to the equals key, it will put in the actual answer from your last calculation and give you a much more accurate answer. So let's just do one more. Okay, we'll do this one over here. So start with y, so sine y. Okay, don't write y on its own, it has to be sine y, divided by 14 equals sine 48 divided by 11. Okay, so that means sine y is equal to 14 times sine 48 divided by 11, and I'm going to work out what that is. So sine y equals, that's 0.9458, and it just carries on. So y is equal to the inverse sine of 0.945, oops, it's meant to be a 5, 8, remember you can just press the answer key there, equals 71.1 degrees. Okay, so try that, see if you can get the answers, learn how to use your calculator, and especially the answer key is really useful, because if you can use the answer key effectively, it gets rid of any errors, okay, and you get a much more accurate answer. Right, and here's 4 questions for you to try, and as always, pause the video, give it a go, and then you can compare your answers shortly. Right, so I'm just about to reveal the answers, so here we go. Alright, so check through your working and see if you've got them right. If you haven't, make sure you can see where your error is. Okay, and yeah, if you've done that, let's move on. Okay, and lastly, we have a special case scenario, and this is where the unknown angle is obtuse. And you might wonder why the angle doesn't just come out as an obtuse angle. And the reason for that is this, because if you did the sine of 30, you'd find it's 0.5. But if you did the sine of 150, you'd find that's 0.5 as well. So when you're doing your calculation, at some stage you end up with sine x equals something. And if that something was 0.5, then when you do x equals the inverse sine of 0.5, you're going to get 30 degrees. Okay? But what if the angle was 150? Because the sine of 150 is also 0.5. So you don't know which one of those angles it came from. Okay? So normally in the question it tells you it's an obtuse angle, and then that's enough information for you to then go ahead and work out which the correct answer is. Okay, and I can also explain it using the sine curve. So the sine curve looks like this. Okay, so this is 90 degrees. Okay, so your acute angles are on this side here. But if that's 0.5, okay, the 0.5 can come from an acute angle, so say if that was 30 degrees, or from an obtuse angle, which would have been 150. So hopefully that explains why there's two answers to the question. Now, the other thing that can happen, well, the other way to explain it is this 10 centimeters, it could have been 10 centimeters over on this side here instead, okay? Which means it could have been an acute angle, or if it's over here, it could be an obtuse angle, all right? So that's the other reason why you might get two answers, all right? So look at the question carefully and make sure if it says x is obtuse, that you deal with it in the way I'm about to show you how to deal with it. Okay, so let's just start off. So you start off with sine x. Sine x divided by the opposite side, which is 15, equals sine 30 divided by the opposite side, which is 10. Okay, so sine x would equal 15 times sine 30 divided by 10, and then you work out what the answer to that bit is, and that equals exactly 0.75. And what I do then is I say x equals the inverse sine of 0.75, which equals 48.6 degrees. Okay, and what you need to do is you need to say, well, I need an obtuse angle, so that can't actually be the right answer. So this actually can't be x. Okay, so the inverse sine of 0.75 is 48.6, but what I need is an obtuse angle, and the way to do it is you just subtract this from 180 degrees. So you do 180 take away 48.6, and that equals 131.4 degrees. Okay, and that is the correct answer. So I've got one over here for you to try. So pause the video and I'll go through the working in a few minutes. Not in a few minutes, in a few seconds. Okay, so I'm just about to reveal the answer. And there it is. Okay, hopefully you got that right. If you didn't, go back and look at it again and see what mistakes you may have made. Right, well, that's it. That's the sine rule. And in the next video, what I'll be doing is looking at the cosine rule, which is also used for non-right angle triangles, and we use that in a slightly different scenario, and that's when the question involves three sides and an angle, where it's one of those four things you're trying to find. But we'll have to wait for that till next time. Anyway, that's it for now. Goodbye.